Talking about our costs, last week we have finished the introduction, the first chapter, and now we are moving to the second chapter. So first chapter, I think I have already given you the overall idea about the urban water cycle, including the distribution system, the water treatment uh, processed, and wastewater treatment processes, and other facilities relevant to these infrastructures. So hopefully you get some idea about what we are going to discuss in details in the next chapter. But anyway, the chapter two, which we are going to talk about today, is still more or less the introduction. But I will not spend much time to talk each of every slide as I told you previously. So it's your responsibility to study by yourself. We had 3 hours lectures, but you are recommended to spend at least 6 hours a week to uh, study by yourself, so that our teachings and learnings will be very effective. Okay, so last week we have completed the first chapter. So for the second chapter, I think you can download the reading materials, the slides from the MS team. Okay, now I will just share the screen. So you are now with my presentation. Uh, I'm using this application preview. So if you don't see my presentation, just tell me. Okay, for the second chapter, the title of the chapter is the water supply and sanitation. So the second chapter begins with the aspects relevant to the waterborne disease. As we know that why we have to remove all the contaminants or the pollutants from the water to produce the drinking water, because we're concerned about the consumer's health. So if the water get contaminated with the contaminants or the pollutants, so it might cause it might cause the disease. So the disease that uh, related to the water usually is defined as the waterborne disease. So basically, the definitions of the waterborne disease is water-related disease. Okay, uh, in some way related to water or the impurities in water. So there are a number of diseases that has related to the water or the contaminants in water. Uh, in these presentations, I have collected statistical record that relevant to the waterborne and the environmental related disease. So you can have a look. The disease which is widely known as the waterborne disease is the diarrhea. So if you drink the contaminated food or the contaminated water, you can easily get the diarrhea. And this is like malaria. Malaria is also waterborne disease. Do you know why? Because as we all know that the malaria, this disease, the vector that can actually transmit this disease is the mosquito. The mosquito, they actually spend part of their life in water. That is why malaria is also classified as the waterborne disease, because in some way they're related to the water. Okay, the major cause of the disease is related to the water. That is why we consider malaria as the waterborne disease. So here you can find lots of the statistical record that this record that you can, if you are really interested, you can study further by visiting the websites of the WHO, or uh, find out from our sanitation report. Here is the this is influenced by the poor environment. Uh, Gets or drink the water contaminated with the pathogens, people may get a diarrhea. Some this is like a lower respiratory infections, maybe caused by the poor air quality in the atmosphere. Various form of the unintentional injury. Take for example, the visibility is not clear due to the particulate matter cover the area. The major cause of the particulate matter spread all over the areas may be due to the open burning like that, and that finally caused the accident. So this is also a kind of unintentional injury which caused by the poor environment. Malaria, as I said, it's also related to water. So we also classify the malaria as a waterborne disease. So these are some examples of the major diseases that could actually causes by the poor environment. If we want to minimize the episode uh, or the number of cases that suffer uh, uh, from the disease caused by the poor environments. So what we can actually do it as government agencies or the authorities in charge, they should actually promote the safe household water storage. Uh, there should be some specific agency working on this issue, especially in the developing country. Uh, Use of the cleaner or safer fuels so that some kinds of airborne disease can be suppressed or can be minimized. But anyway, a changing of fuel types from the past to the present also create some of the emerging pollutants. In the past, in Thailand, I think it's been about um, uh, over 20 years ago, uh, 20 or 30 years ago, in between 20 to 30 years ago, uh, the our country has used fuels, gasolines with the lead as the additive. So during that times, in the air, there are a lot of lead. Lead is the heavy metals, as you are aware of that. Uh, as they are a heavy metals, and then once it get into, it's actually there in the air because of the exhaust from the vehicles, especially in Bangkok area. At that times, the people who live in the who live or work in on the curbside, they uh, they get a lot of lights into the respiratory system or get into the body, and finally it really affects the brain, especially in children, and cause some malfunctions to some inside organisms. So this is a kind of the effects of the lead uh, onto the human body at that time. But now we are not using a lead anymore. We are using the gasohol. So it is basically the combinations of the gasolines and the alcohol. So this kind of fuel, it's actually more cleaner as compared to the past, and it does not create much greenhouse gases. But you know, as the alcohol is used, it is added into the gasolines. So alcohol, as we all know, that the vapor pressure is very low, so it's easy to vaporize. And as it easy to vaporize, what will happen? So it may get into the air easily. So if we measure the air quality, we could actually find some kind of the pollutants called volatile organic carbon, VOC. So this time in Bangkok, we could find lots of VOC in the air. Uh, uh, a lot we could find as compared to the past. So as we change the technology or the raw material anyway, we will have to study further about the effects of that changes, because all the changes could actually pose us some kind of effects. Uh, we are only focused on the positive uh, sides, but sometimes we ignore the negative sides, or sometimes we concern both sides, but the negative sides it takes quite a long time to show up. So that is also the problems. Like in the past, people were using the DDT. DDT is the pesticide. Have you ever realized that the scientists who developed this kind of chemicals that can be used to control uh, the the pests, which can actually cause a lot of damage to the farmers. The scientists who developed or who create this DDT actually uh, received the uh, Nobel Prize uh, as a scientist who could actually make change to the world. But anyway, after we used these chemicals, pesticides, this DDT for a long time, then we experienced some environmental effects. For example, the DDT could actually inhibit some of the mechanisms in the birds, so the birds cannot actually uh, reproduct uh, effectively. Usually the birds they lay the eggs, but some mechanisms that are actually uh, uh, make the eggs stronger, like creating the calciums covering the egg shells. So this mechanisms is a kind of is uh, uh, inhibited by the DDT, so that finally it actually affects the reproduction process. So this is one of the example that caused by the DDT. Uh, the examples that actually discover several years after the first uses of the DDT. So DDT finally becomes the pollutants to the environment, and we are now banned it. We don't use these chemicals anymore, but we look for other types of the chemicals. So for other types of the chemicals, we usually uh, 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 think it is new, so it is safer. But for the effects, we still have to study. So it may not create the short-term effects, but it may create the long-term effects. So once we experience the negative effects, so it may take like 30 years. So during these 30 years, people already get uh, contaminate or get these pollutants inside their health, and could actually end up with some long-term disease like cancers. Uh, Increased the safety of the built environment, uh, more judicious use and management of the toxic substances in the home and workplace. Of course, this we need to do it. Better water resource management. So uh, uh, some kind of disease could actually caused due to the shortage of water. So if we could actually manage our water resources, supplying sufficient water to the community year round, maybe we can reduce the environmental effects, environmental disease. Uh, these are the statistical record that for the disease from the environmental factors, diarrhea. Uh, it's really interesting if you look at this uh, term, DALYS. DALYS stand for disability, disability adjusted life years. Okay, disability adjusted life years. So you can uh, look for this term in the internet, from the internet. Basically, the DALYS, disability adjusted life year, is the measure of the disease burden. Is the disease burden. So it's referred to the total time lost per year. Uh, the loss is the total time loss is basically due to the disease. For example, the diarrhea, the total time lost is 58 million years per year. So people all over the world actually suffer from this disease, the diarrhea. But so after suffering, so what they will have to do, they have to take a short break. They cannot work. They have to leave the office and get some rest. So this we consider as a loss. So the loss uh, uh, due to this disease, we can actually call the disability adjusted life year. It's the measurements of in terms of times. This measurement is expressed in terms of times. So in 1 year, the people all over the world, we had lost 58 million years per year. Okay, so in 1 year, the total time lost is 58 years due to this diarrhea. So it's really interesting if you look at this disease. So the higher total time loss means uh, uh, the more number of the episodes or number of cases caused by this disease. Lower respiratory infection is 37 million years per year. Unintentional injury is also high, 21 million years per year. Malaria and road traffic injury. So these are the statistical records. So you may, if you're really interested to this term, you can file the definitions on the internet. But anyway, it's really interesting for the people who live in Bangkok. Uh, if you if you look at the total time lost, so nowadays we had lost a lot of time so due to the transportation. So if you go for meeting in Bangkok from Thammasat University, so you have to leave at least 1 hour for the transportations. But sometimes if there is a traffic jam, you may need at least 1.5 hours to reach the downtown of Bangkok. So this is a kind of total time loss, but it's the loss due to the traffic condition. So if one could actually measure this loss and then compare with the disease, I'm sure that the loss due to the traffic congestion would be much higher than the total time loss due to this disease. So once you have complete this third year, so next year you would have to do the projects. So if you are really interested, one could actually measure the loss. Maybe if you are working with Ajahn Vinay, you could propose these topics. Just to see the damage, economic loss due to the total time lost caused by the traffic congestion. Okay, so you can actually reach all this statistical recorded. Morbidity, it's the number of episodes per year. The diarrhea disease is as high as 1 billion episodes per year, but diarrhea disease still could cause a death. The mortality rate or the number of deaths per year is still high, 3.3 million deaths per year for around the world. But in our country, diet from a diarrheal disease may looks impossible, but in some continents that they have not gained access to the improved sanitation, the diarrheal disease is still matter to to those countries. Infection with intestinal helminths. Helminths แปลว่าอะไรฮะ Helminths แปลว่าอะไร Has anybody with my presentation right now
พยาธินะครับ
โอเคพยาธินะ in the early morning actually not very early, so it's now 10 o'clock already, so please wake up. Okay, พยาธินะ infection with intestinal helminths still cause a lot of deaths, 0.1 million deaths per year globally, and cost 1.5 billion episodes per year. 30 years ago, in between 20 to 30 years ago, people in the northeastern part of Thailand, particularly in the northeastern part of Thailand, they really suffer to this disease, Helminths disease. So at that time, the people, they are not really well educated. So they think like the freshwater fish is clean. They usually eat that fish without properly cooking. So it's not really, completely broiled or not cooked properly. So in that case, if the fish meat is not properly cooked, some of the helminths eggs is still alive, and once they eat that kind of fish, so the helminths eggs can actually get into that body and cause the disease. So at that time, many people actually suffered from this disease. But nowadays, this disease, the number of episodes is still there, but not in a significant number. But anyway, this is also one of the diseases that has very close link to the poor sanitation. Schistosomiasis and poliomyelitis. These two are also the protozoa. The disease caused by this protozoa. The number of episodes is not that much high, but still give a significant number in some continents. So these are the global scenario of this is related to the poor quality of water. For the waterborne disease, we can actually classify the disease into 4 major types based on the transmission mechanisms. So the first transmission mechanisms is the waterborne mechanisms. So just like the named waterborne disease. So what is the waterborne mechanisms? So waterborne mechanisms is the disease caused by the pathogens, which is present in the water drunk by the persons or animals which may become infected. So what does it means? It means that we drink water, we consume the water, the contaminated water, or the water contain some water containing some pathogens, the pathogens that has the potential to cause the disease, and finally we become infected. So this is the kind of the disease transferring transmission due to the first mechanisms. For the second mechanisms is the second mechanisms is the water wash mechanisms. Water wash mechanisms is just like we don't have sufficient quantity of water uh, uses for the personal hygienes. For example, uh, before having a food, what you really need to do first, you are recommended to wash your hand before eating every times, every meals, before bring something, some food into your mouth. You should actually clean your hands. Cleanings, of course, need water. Okay, if uh, there's no sufficient water, good quality water, what will happen? The people try tends not to use that water, and finally, no cleaning before eating, no hands cleaning before eating. So it's easy to bring some food. Contaminated food into that body, into the body. So this is a kind of finally the people will get infected. So this is a kind of the transmission mechanisms due to the shortage of water. These mechanisms we normally call the water wash mechanisms. The third one is the water-based mechanisms. Water-based mechanisms is just like the case that I have just talked about. The helminths, they usually stay or live in aquatic animals or water snails. If we uh, catch these fish or the aquatic animals and eat them without cooking properly, then we could infect. Uh, we could be infected by the disease. So basically, the pathogens are spend part of their life in water snails or the aquatic animal. That is why if we eat these organisms without cooking properly, we could get the disease. So the disease transmitted by these mechanisms, normally we call the water-based mechanism. So if you want to avoid this kind of transmission, you should actually avoid eating this water snail or some particular types of the aquatic organisms uh, that may contain some of the helminth's eggs. Uh, the last transmission mechanisms is the water, is the insect vector mechanisms. So this is a case of malaria. The disease spread by insects uh, which breed in water or bite near water, just like a malaria. So the disease is being transmitted by the mosquito. So this transmission mechanisms we normally call the insect vector mechanisms. Okay. So these are the photographs of the Ascarids eggs. Ascarids is also the helminths. Uh, the eggs can be easily found in the night soil sludge sample. So again, what is the night soil? Night soil is basically the human excreta all the solid matter in the septic tank. So normally we call the night soil. Sometimes we call it night soil sludge. The night soils normally we can easily find this kind of eggs. uh, Talking about the preventive strategies. So if we want to minimize the this is caused by the waterborne mechanism. So what we can do, we can actually improve the quality of drinking water. Chlorine needs to be there in water, needs to be present in the tapped water at the point of use. So at the point of use, chlorine residual should be approximately 0.5 ppm. So at least it should be 0.5 ppm. So this is actually sufficient to inhibit the pathogens or inactivate the pathogens, or prevent a casual use of other unimproved sources. Just like when we harvest the water or withdraw the water from the river, we try to withdraw the water from the upstream to the city. So we don't withdraw the water somewhere near the cities or inside the cities, because there's a lots of chance of contamination. So we try to avoid this site. In Bangkok areas, the point we collect the sample, it's located in the Pathum Thani province, in the Samkhok district. Actually, it is not far from our university. So if you are interested, you can visit there sometime. It's just behind our university. So this is upstream to Bangkok. Uh, this is the location where the waterwork authorities that designed to locate the intake facilities several years ago. For the second transmission mechanism, so how we could prevent disease transmitted due to these mechanisms, we can actually do the we can actually increase the water quantity used. Uh, 200 liters per capita per day is quite sufficient, but if you use only 50 liter per capita per day, it's very questionable, because you used too less water quantities. I mean, much lesser than the average. Maybe you don't have good uh, uh, hygienes in your daily life, so you should actually consume more water. So basically, we need to increase the water quantity. Before eating, we need to wash our hand uh, and make ourselves clean, especially during this time. So once we get back from outside, you should take out your cloth. You should take a shower immediately. Because if you go outside, you have a lot of chance to meet the people. You have a lot of chance to meet the people that may carry the disease. I'm not talking about the COVID-19, but for other diseases. So this time, it's really important to change the behavior. Once we get back, then we take out our clothes, we clean our hands properly, and immediately after, get back to the home. So this is a kind of the preventive strategies for the water watch mechanism. So improve accessibility and reliability of the domestic water supply. If you're living in Bangkok, so you're lucky because the water supplying system is very reliable. So a few times that I could see they temporarily stop supplying, but mostly they can actually supply water 24 hours continuously. Comparing with some municipalities in the provincial areas, sometimes they supply and every once in a week they have the problems with the water supply systems. They could not supply clean water. So this is also a kind of the problems that we need to tackle if we want to prevent the disease transmitted due to the water wash mechanisms. Improve the hygienes. Uh, for water-based mechanisms, just decrease the need for contact with the infected water, control the snail population. Snails, as you may know, that they mostly live at the tops of the bottom sediment. So at the sediments, there will be lots of pollutants or contaminants accumulated. So including the toxic substance in the sediment. And these snail, they actually live at the tops of the sediment. So it's quite clear that they have lots of chance to get it contaminated with the some pollutants, some pathogens. Not just the snail, but or other organisms that live at the tops of the okay. Now my screen it's showing the OneNote application. So hopefully you could see this screen. Okay. So the problem is like this. So this is the surface, water surface. Okay, and this is the bottoms of the river or of the lake. Mostly the toxic substance tends to accumulate it at the bottoms of the river, so the lake. And if there are some aquatic organisms live on the tops of the sediments, the tendencies of getting contamination or exposed to the toxic substance is very high as compared to other types of organisms that lives in the waters or near the water surface. So we try to avoid eating these kind of organisms, including that are snails. So these benthic organisms is a kind of organisms that we should not eat if it is not necessary. So because why the benthic organisms, they actually has the very high chances of getting contaminations with the toxic substance, because at the bottom of the river or the bottoms of the lakes, there will be lots of toxic substance accumulated, because mostly suspended particle will finally settle to the bottoms of the rivers or the lake. So we have to be careful while eating these types of the organisms. So avoid eating, avoid contacting with these contaminated organisms is the best way to prevent the disease transmitted due to the water-based mechanisms. Reduced contaminations of the surface waters by excreta. For the water-related insect vector, it's important to improve surface water management. There is something wrong with my cursors in this computer. Sometimes it doesn't show, but anyway, I think everything's will be fine. Okay. Improve the surface water management, destroy the breeding site of the insects, um, decrease the need to visit the breeding sites, and the house should equip with the mosquito netting to prevent the mosquito entering to the house. So these are the summations of the preventive strategies to each transmission mechanisms. But anyway, concerning about the our jobs, our environmental engineering work, we are working on the improving the quality of the drinking water. So we are trying to treat the contaminated water to produce the drinking water. We are trying to treat the wastewater to becomes the water that can be discharged to the natural receiving stream. So mostly our jobs focus on the improving qualities of the water. So basically, our work is related to the first transmission mechanisms. Uh, Sometimes we are working on the increase the water quantity, okay, but mostly we are working on the improving the qualities of water, so that we can say that as the environmental engineers or water engineers, water resources engineers, we are dealing with these two issues: waterborne preventive strategies to the waterborne transmission mechanisms, and also the water wash transmission mechanisms. We are not directly do the preventive strategies due to the water-based and the water-related insect vector. These are not our jobs. I'm talking in general, okay? But we will do more on the improving the qualities of water, so that these jobs will help to prevent the disease transmitted by the waterborne mechanisms, and sometimes water watch mechanisms. Uh, Okay, so that is all for the waterborne disease. So hopefully you get some idea about the water related uh, disease. And now we're going to talk about the water and its impurity. Uh, Talking about the water, I think everybody knows about the water characteristic, and some impurities I have already introduced in the first chapter. So you can go back and then find out for some details. Hydrological cycle. These cycles you have studied intensively in the hydrology course. So I think you are quite understand the cycle of water in our Earth. Uh, the source of contaminants. There are two major sources of contaminants. The contaminants could come from the human activities, and it also could come from the nature. For example, volcanic eruption, mud slides, landslide during the wet seasons, so that the river carries a lot of sediments along by. So this kind of contaminants could actually causes by nature, but the contaminants causes by nature, it doesn't take much time to to be removed uh, uh, by the nature itself. But for the contaminants caused by the human activity, mostly they are also the pollutants. So it takes a lot of time, and it sometimes uh, caused a harm to the environment. So now we need to deal with both sources of the contaminants that may carry or bring the contaminants and pollutants into the water. Uh, the impurities or the contaminants or the pollutants in water, we can actually classify that into based on the objects. We can actually classify it into the living organisms or non-living organisms. For living organisms, for example, the microorganisms, bacteria, fungi, protozoans, or the pathogens. Here we are not talking about the large aquatic animals like a fish or some other. So we are talking about the small or microorganisms that could actually becomes a part of impurities when we withdraw water to produce the drinking water. Uh, Other types of the impurities can also be classified as a solids or dissolved, or it can be classified as the organic matters or inorganic matters. For the organic matters, mostly human excreta, animal manure, a cow manure, uh, some other animal manures. They are mainly the organic matter, so we have to treat them in such a way that preferable for the organic substance. For the inorganic matters, for example, the heavy metal, dissolved metals, radioactive elements. So these are uh, classified as the inorganic matter. Some of them are dissolved and some of them are solids, exist in the solids stage. So these impurities, it's normally these impurities are normally there in water. So we can classify it according to these categories. Very interesting if we talk about the water and its definitions. So if we are talking about pure water essentially means just the H2O. Okay, just the H2O. Hydrogen's two atoms and one atoms of oxygen associated with each other become H2O, and this is the pure water. Okay, pure water, you may think about the distilled water or the deionized water, water with free of iron, water with free of everything. So it's just H2O. So this kind of water normally we call a pure water. But the water that we can consume or the water that we can use is not free of everything. So some of the mineral get dissolved, some of the contaminants get, some of the impurities get in there, but it doesn't cause any harms to the human being. So in that case, we normally call it potable water. Pot means a vessel, right? We used for a cooking, so or keep the water. So potable water means the water that we can consume, or water that we can drink without causing any harm to our health. So this is the definitions of the potable water. So potable water is totally different from the pure water. Okay. For the contaminated water and the polluted water are also the same as the definitions of the contaminants and the pollutants. Polluted water means water uh, with the pollutants or with the contaminants. So with this one, we have to remove them all from the water before releasing this water to the environment again. So contaminated water or the polluted water somehow refers to the wastewater. Okay, so these are the definitions of water. Talking about water characteristic, this table shows the comparisons between groundwater and surface water. What parameters we are interested? What the parameters that we are interested are the hardness, alkalinity, dissolved oxygens, carbon dioxide. So these parameters today's afternoon, we will do the labs. We will do it in today's afternoon. Alkalinity is the basis neutralization capacity. By the definition, alkalinity is the basis neutralization capacities or the capacity to neutralize the the acid. Sorry, alkalinity is the acid, not the basis. Sorry, acid neutralization capacity ANC. Okay, alkalinity is the acid neutralization capacity ANC. So the higher alkalinity will be the higher capacity of water to neutralize the acid. So that is the definitions of the alkalinity. So for acidity, it's uh, opposite. So the acidity, it's the basis neutralization capacity. The higher acidity will be the better, or the higher the basis neutralization capacities. Okay, so you see the values of the range are not the same. For groundwater, hardness is very high as compared to the surface water. It's similar to the alkalinity. Groundwater it's a little bit higher as compared to the surface water. Dissolved oxygen, groundwater, the dissolved oxygen is nearly zero because they are groundwater. They are not exposed to the oxygen in the atmosphere. Carbon dioxide, surface water it's low, but groundwater it's tends to be higher because as you know that in case of surface water, the water is exposed to the oxygen, while the carbon dioxide presents only a small portion, so that for the surface water, you will not be able to find carbon dioxide dissolved in water sample. But you will find a significant amount of carbon dioxide in groundwater. Calcium hardness and magnesium hardness tend to be high in case of like groundwater, but sometimes high, but usually low in the case of the surface water. So today's afternoon labs, we will also talk about the hardness. We will talk about the alkalinity. So hardness include magnesium's hardness and calcium's hardness. So this is in terms of the positive charge ion, but in terms of the negative charge ion, hardness can be classified into the permanent hardness and temporary hardness. But the details, we will talk about it again in the afternoon and sometime after the midterm examination, because it's already there in the chapter. You can see the difference between surface water and groundwater. So if I ask you which one you prefer to use as the water supplying source, so which one you prefer, groundwater or surface water? Which one you prefer in terms of the quality of water, in terms of the quality? Surface water. Uh, just a moment. So somebody has just visit my home, so I need to see so who is coming. แป๊บหนึ่งนะครับ
ผม
ตอนนี้ไปเบรกก่อนก็ได้ครับครับ
โอเคฮะอันนี้เป็นปัญหาของการนะฮะสอนอยู่ที่บ้านนะครับokay, so just continue what we had talked about. Okay, just the comparisons of the groundwater and surface water. So you see these two are somehow different. So if you use the groundwater as the source of water to produce the drinking water, you have to pay attention on the hardness removal, and you may have to somehow increase the dissolved oxygen. อันนี้ได้ยินเสียงผมนะฮะ
ยินครับ
ได้ยินครับ
ครับ okay, but for the surface water here this in this table they don't mention about the suspended particle or the suspended solids. If they show the suspended solids or the turbidity, you will find surface water contains lots of the turbidity, while groundwater the turbidity it's nearly zero. So for the surface water, you need more complicated system to remove the suspended solids. So these are the difference between a groundwater and surface water. For the characteristic of the water and wastewater, we can actually classify into 2 or 3 major characteristics. Physical characteristic, if we talk about the physical characteristic, means we talk about temperature, turbidities, and probably color. Chemical characteristic means we talk about the pH, hardness, and probably dissolved solids. Biological characteristic may involve the presence of the pathogens, some microorganisms like algae, bacteria, protozoas, or viruses. Radiological characteristic, some impurities like uraniums or radons, but this kind of characteristic in Thailand we are not paying much attention because the sources of the radiological substance is very few places they used this kind of substance, radiological substance in Thailand. So we don't pay much attention on this substance. But in some country like in Japan, maybe this is one of the most interesting contaminants they have to investigate it since the tsunami in 2004. Okay, talking about the water quality standard, this is we are going to talk about why the standards is important, and also how the country or the community can actually establish this standard. The standards normally refers to the definite rule, principle, measure, of course, established by the authorities. Water quality standards in Thailand normally are established by the pollution control department, and each municipalities they also have authorities to create or to launch their own standard. But anyway, the standard that they have make up, they should actually related to the intended use of water. As I mentioned in the lab session last week, for the intended use of water, we can classify the surface water into 5 types, type 1, 2, 3, 4, and 5. So the best quality it's type 1. So type 5 you can only use for the navigation. So if you visit some canals in Bangkok, you will realize the qualities of water in that canal fall into type 5 because you cannot do anything, only traveling along that canal, especially once you graduate from this faculty. If you like to apply for the engineering license, you have to visit the councils of engineers. So you have to submit the documents at this office. So do you know where this office is? So this office is located in Ramkhamhaeng area in Soi Thep Lila 39. So one of the most convenient way to reach these areas is by boat along the Sansap canals. You may get on the boat somewhere near Pratu Nam and then traveling along the canals and get on the piers at the Wat Thep Lila and then catch or take the motorbike taxi to this office. So that is the most convenient way to reach this office. But that is the past, okay. But this time it may be convenient if you drive. I'm not sure, but at the times I was just graduated, I do this way. So class 5 is a kind of a poor quality. The quality the according to the quality we cannot use it, we cannot even take that water and use for agriculture because it's too dirty. So when we set up the standard, so it should be related to the intended use of water. There are two approaches to set the standard, to set up the standard. The first approach is the governmental stipulation, and the second one is the policies of the minimum degradation. Most of the countries all over the world, I think not most, I think it's 100% of the countries all over the world, they set the standard by using the first approach, the governmental stipulation. So what does it mean by the governmental stipulation? So the standard is actually proposed by the some authorized agencies in that communities or in that country. So they have studied, they have gathered the scientific information. For example, talking about the turbidity. So what could be the maximum allowable turbidity? So they have a study uh, uh, based on the scientific results. So maybe less than 10 NTU, that may be good enough for drinking. In terms of the economical attainability, maybe 5 NTU it's good, because if they are actually make a two, the industry has to invest a lot of treatment technologies to bring the turbidity from 10 or 5 into less than 2, like that. So they start the value, so and then pick up one of the most suitable value for each individual parameters. I just give the examples about the turbidity. So what should be the values of the turbidities? Why finally it comes as the 5 NTU. 5 is not too high and also not too small. Of course, if you are thinking about why the government don't put 0, so 0 it's good, but it's not economical attainability. Economical attainable, because 0 is possible only when we apply an advanced technologies to bring the suspended solids down to 0. But it's meaningless because even there are some certain turbidity there, 1 or 2 NTU, it still can be safe for drinking. Why we have to go for 0? So this is a kind of how the government agencies or the authorities in charge, they set up the standard. That is why this kind of a standard it's set up based on this approach. Okay, based on the governmental stipulation approach. So I'll give you some example of the standard setting up by the governmental government agencies, like this one, US EPA standard. So last week I have shown you the standard developed by or established by the Pollution Control Department in Thailand, but in US there are also the agencies like the Pollution Control Departments, but there the people call the US EPA. US EPA, it's the EPA stands for the Environmental Protection Agency. You may have heard about this agency sometimes. These agencies, they actually establish the several water quality standards and also other environmental quality standard. But for the drinking water quality standard, so here are the list of parameters and the maximum containment levels. There are a number of parameters. Start with A, arsenic should not be higher than 0.5 milligrams per liter. Milligrams per liter or the ppm are equivalent with each other. So for the contaminants in water, if the unit is 1 milligrams per liter, it also equivalent to 1 ppm. So we can say that 1 ppm, ppm and milligram per liters are basically the same unit in case of water as a solvent. Okay, so bacteria should be maximum value should not higher than 4 per 100 ml. Barium, benzene, cadmium, carbon tetrachloride, cyanide shouldn't be higher than 0.1 ppm or 0.01 ppm or 0.01 milligram per liter. Dichloroethylene, aldrin, linden, methoxychlor, dichlorobenzene. So these are the name of the pesticides. These are the names of the pesticides. Some are lower and some are high. I'm talking about the maximum containment levels. For aldrin, the value should not be higher than 0.0002 milligrams per liter. So according to this number, what does this number tell you? The lower value or the smaller number indicates the higher toxicity of each pollutants. For example, if you compare the DDT, dichloroethylene, with the aldrin, which one is more toxic? So you will find aldrin it's highly toxic because the maximum allowable or the maximum containment level is just 0.0002 ppm. But for DDT, maximum allowable value it's 0.005. So in terms of the toxicity level, so aldrin it's more toxic. So this number can actually tell you about the toxicity of each pollutant. Mercury 0.002, mercury 0.002, and then what else? Copper, which is one of the most well-known heavy metal. The maximum containment level could be 1 milligram per liter. This is quite high as compared to other types of the pollutants. So you can have a look here, the drinking water quality standard. See the turbidity silica scale. So it should be in a range of 1 to 5 turbidity scale. Silica scales in here refers to the nephelometric turbidity unit or NTU. So it's in between 1 to 5 NTU. If you could bring smaller than 1 NTU, that is fine, but typical value should be in between 1 to 5 NTU, or generally speaking, should not be higher than 5 NTU. Zinc, one of the most well-known heavy metal, maximum allowable can be as high as 5 milligram per liter. So these are the list of the parameters that shouldn't be in a higher amount. It shouldn't be higher than the value shown in this table. Radionuclide, gross alpha particle activity, beta particles and photon radioactivity, radiums to 26 and to 28 shouldn't be higher than this level. So these are the these are one of the example of the standard setting up by the first approach. So the first approach, they usually mention about the standard and describe lots of parameters, and the parameters should not be higher than the value they have proposed, and the unit is milligram per liter. So these are the standards setting up by the first approach, the governmental stipulation. In the English words, there are several words similar to the standard. The standard, criteria, regulations, and guidelines. So these are similar, but they are not the same. Only the standard is legally enforceable. Okay, but in Thailand, according to our language, sometimes the standard doesn't always refers to something which legally enforceable. Sometimes it's just like that, but in general, in the English world, standard is legally enforceable. Others are not. Regulations and guidelines are just some things developed to define how the standard shall be met. And criteria, it's a recommendation. Criteria, it's more or less recommendation. Like if you are going to design the beam with the span 5 meters, so what you should actually do, so that is the criteria. So you should put at least this amount of the steel to reinforce the concrete beams like that. So these are the criteria, but criteria, it's something you can follow, or if you have a good reasons, you don't have to always follow the criteria. You can following or not following, it doesn't matter. It doesn't affect much in terms of the in terms of the human effects, but it may be related to some other reasons, like economical reasons. So you're recommended to, for example, remove the turbidity to be less than 5 NTU, but you don't have to go to 0. 5 NTU is good enough. So this is the standard, but criteria may be 10, like that. So it depends on the condition. So criteria is just the more or less the recommendation, not the standard. Okay, so these are the difference among these terms. Okay, other types of the approach. The second approach is the policies of the minimum degradation. Before I'm going to talk about this one, one thing you should really need to understand that the stream, each stream or lakes, they have their own, they have their own capacity to receive the pollution. The stream, once it gets, the waste, once it get into the water. So I'm now on the OneNote application page. So hopefully you can follow these applications on the screen. Okay, so this is the screen. Sorry, the stream. So if we discharge the waste here into the stream, what will happen? So waste entering to the stream at this position, what will happen? Remember that waste may contain some organic substance. The waste may contain some suspended solids. So you should familiar with this term now. So if you don't really understand this term, please study by yourself. These are very common terms that I regularly mention about. Another thing is the BOD. So BOD, it's what? It's equivalent to the amount of the organic substance present in water. Okay, the higher organic substance presence will be the higher BOD value. So BOD, what is the BOD? Again, the BOD, it's the oxygen, the measurements of the oxygen equivalent to the organic substance. So the higher organic substance dissolved or presence in water will be the higher amount of oxygen required to degrade this organic substance. The measurements of the oxygen equivalent is actually the BOD value. So BOD normally means the oxygen equivalent to the organic substance, and the organic substance, the higher organic substance presence will be the higher BOD value. So the higher degrees of the contamination will be the higher BOD value. So BOD, the higher BOD value showing the higher degrees of the contamination. So this term, if you are not really familiar right now, so please study by yourself again, because I have mentioned it many times. So I will mention from now on, I will mention this term very often, and I probably have no time to explain it one by one from time to time. Okay, so the wastewater are discharged into this river with the flow rate QW. So this is the flow rates of the river divided as the QR. So wastewater containing some organic substance and containing some of the suspended solids. Okay. For the suspended solids, once it enter to the stream, what will happen to the suspended solids? So for the suspended solids, as it is uh, 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 heavy somehow, so if the density is higher than water, so how it move in the stream? So it will move like this. So it will move along with the water in a horizontal direction, and somehow it will move down to the bottoms due to the gravitational force. So according to this movement, so finally the trajectory lines of movement of this suspended solids will be something like this. So this is basically the resultants of this one and this one. Okay. Finally, what will happen to these suspended solids? So these suspended solids will finally settle to the bottoms of the chamber. Okay, so this phenomenon normally happen in the natural water resources. So sedimentation will take place. Sedimentation will take place, okay, in the nature. And then what else? The organic substance get degraded by the bacteria in the water. So in this case, the purifications of the organic substance in water can actually happen by the natural process. So the degradations of water we generally call the biodegradation. And comparing with the wastewater flow rate, comparing between the wastewater flow rate and the river flow, which one is normally higher? The river flow rate, it's normally larger than the wastewater flow rates. Wastewater flow rates like we discharge a small quantity of water into the Chao Phraya River. So if we are just a house, and then if we discharge the black water into the river, So our in terms of volumes, our wastewater is quite small as compared to the flow rate in Chao Phraya River. So in that case, what will happen? Our wastewater will get diluted. Okay, so there will be a dilution. So with these three major mechanisms, our wastewater will finally, uh, uh, never exist in uh, things like uh, uh, contaminated or like a waste, because the waste is all diluted. Some of the substance came along with the waste is actually get degraded or being removed by some way due to the natural processes. So these are the things which normally happen in water. But the problem is, if our community has more number of wastewater sources, what will happen? If our community has more number of wastewater sources or the pollution sources, what will happen? So the bacteria, they don't have much the oxygen present in water with the concentrations just approximately 5 milligram per liter only. So if too many sources discharge to wastewater, maybe uh, the stream may not have enough capacities to clean up. They may not have enough oxygen supplying for the degradations. Uh, in terms of the flow rate, especially during the dry seasons, when the water in the river is small, very small flow rate, while the wastewater flow rate remain the same or increased. So in this case, you will find the qualities of water it's not that good. I mean, the quality of water in the river is not that good because it's being deteriorated. Then finally, uh, the stream will not have sufficient capacity to clean up uh, this pollutant. I forget something. These three mechanisms we can actually call self-purification process. Self-purification process. Okay, the stream, they have their own capacities to clean up themselves, and the purification process here we call a self-purification process, which include the dilution, sedimentations, and the biodegradation. So these three are the major mechanisms, major self-purification mechanisms. Okay, so uh, this is how the stream will assimilate the waste. Okay, they have their own capacities to assimilate the waste. If you compare Chao Phraya River, which has large volumes of water traveling along by, with the uh, uh, Mapping River, which is just a small stream, especially in northern province like Chiang Mai. The stream, the volumes of water in the stream is just very small. So in terms of the volumes, so you can actually compare which one would uh, be able to receive more waste. Now, of course, Chao Phraya would be able to receive more waste as compared to Mapping River, right? Uh, the volumes is larger, and then the flows is higher, so they have more capacities to receive the waste. But for the for the some small river or some a small stream, they may not are capable to handle a lot of waste entering to that stream. Just think about the Sansep Canal. Sansep Canal is also just like this, so it's just a small canals. It's big somehow, but not that big. Okay, but there are thousands of houses located along this canal, and all houses, they gradually discharge waste into this stream. So it's finally over the capacities. Then the stream end up with the spoilage conditions. So this is the kind of the idea why the second approach to set up the standard are being concerned. So the second approach, they mainly focus on the stream assimilation capacity. Okay, stream assimilation capacity as simulation capacity. Stream assimilation capacity, assimilation process. These three are the assimilation process. So if the diligence is high, then they have more a capacity. If the they have large areas for the sedimentation, then they have the more the higher assimilation capacities. If they could actually provide more oxygen exchange between the atmosphere and the water body, it could be higher than that stream has more assimilation capacity. So stream assimilation capacity has close relation with this self-purification process. So the second approach, they actually look at the stream assimilation capacities, okay, when they set up the standard. So the wastewater sources, for the wastewater sources, sometimes it gets slower. It doesn't respond immediately once I CH เดี๋ยวนะแป๊บหนึ่ง I don't know what's wrong with this Welcome. Sometimes it's fine, but sometimes it gets slower. Okay, so this is the wastewater sources, one source and two source. The second source is here. The waste is discharged with the QW2. This one is the QW1. Q is the wastewater flow rates. Okay. What will happen if we discharge this wastewater into the river? The source one contains the BOD. Now it looks fine. The source one contains BOD 10 milligram per liter, but the second source contains BOD 30 milligrams per liter. Remember that according to the effluent quality, the government agency, they don't allow the industry discharge the waste with the concentration of the BOD greater than 20 milligrams per liter. So 20 is the standard according to the governmental stipulations approaches. Okay, so the first sources discharge the BOD 10 milligrams per liter, and the second source discharge the BOD 30 milligrams per liter. So if you really have a look into these two sources, you will definitely find the second source they discharge the BOD greater than the standard. So this actually violates the law, right? Penalties measures will be imposed to this industry. But anyway, for this industry, these two industry, we only pay attention on the concentration, the degrees of the contaminations. We only focus on the concentration. So, but if we look into the amount of water discharged, if we look into the amount of water discharged, so you will find another issues. So for the first industry, So if the discharge, the flow rates are as high as 10,000, so what is the unit? Cubic meters per day. But the second source is if they discharge the waste with the flow rates just 1,000 cubic meters per day. So which source would create the pollution load? Which source would create higher pollution load? Now I mentioned one more term, pollution load. So which source create more pollution load? If you compare the first and second sources, which one would discharge more pollution? Which one would discharge more pollution? So if under this condition, if you consider this condition, อันไหนทิ้งของเสียเยอะกว่ากัน
ที่สองครับ
The second one or the first
อัน
one?
ที่สองครับที่สองครับ
Second one because you look at just the BOD value, right? Because it's discharged more. But if you compare, if you include the amount of water discharged, so for the pollution load, you can actually determine the pollution load. So the pollution load is actually equal to the flow rate into concentrations of the contaminants of the impurities. So S is the concentration. S is the pollutants concentration. So what is the unit of the concentrations? Milligram per liter. It could be a BOD. So the pollutions that we are interested in this case is the BOD. So in this case, S could actually refer to the BOD value, to the BOD. So flow rates, Q is the wastewater flow rate, whatever the flow rates that carry these pollutants. So here refers to the wastewater flow rates. So for the flow rates, the unit is cubic meter per day, right? The unit is cubic meter per day. So if I'm taking Q into S, what will happen? This is the volume. This is also the volumes. So I can finally report this term as the kilograms per day. And this term, it's typically called the pollution load. Sometimes the people may call the organic load. It depends on the pollutions. If we are interested in the suspended solids, if the S is the suspended solids, we may call the suspended solids load. So it depends on the types of the pollutants that we are interested. But anyway, they are the pollution load. Okay, so if you are taking Q into S, the unit is kilogram per day, and this value is defined as, or it's recognized as the pollution load. So if we are interested in the BOD, as the BOD is the organic substance, so if we take Q into the BOD, so this amount will be recognized as the organic load. Okay, so these are the way we evaluate the organic load. So for the first source, what is the organic load for the first source? The first source, the BOD, the flow rate is 10,000 cubic meter per day, right? And then the BOD, it's just 10 milligrams per liter. So the performance of the discharged water, the quality of the discharged water of the first industry, it seems to be better than the second industry. So for the second industry, they actually violate the law. But if you really have a look into the pollution load that they discharge into the environment, so what will happen here? Can you just convert this amount into kilograms per liter per day? Milligrams to kilograms, just multiply by 10 to the power of minus 6 liter convert get convert to the cubic meters. You have to multiply by 10 to the power of minus 3. So overall, you just multiply by 10 to the power of minus 3. So you converted this amount into kilogram per day. So how many kilograms per day from the first source? So you will get 100 kilograms per day from the first source, right? And then from the second source, the second source, the wastewater discharge from this industry is thousands cubic meters per day, but the concentration is little bit higher than the standard, 30 milligram per liter. So in terms of the pollution load, how much would you get? You will get 30 kilograms per day. Again, what's wrong with my pens แปลกบางทีมันก็ช้าบางทีมันก็เร็วไม่รู้เป็นอะไรนะฮะokay, it finally you will get only 30 kilograms per day. Okay, so if you consider these two sources and if you consider the pollution load, you will find like the second source yield or discharge less amount of pollution load into the environment, but the first source discharge more amount of pollution to the environment. So which industry create more environmental effects to the water? In fact, the first industry create more effects to the environment, not the second industry. But the second industry just discharged something higher than the standard. But in terms of the amount, they discharge less as compared to the first source. So the problem with the governmental stipulations is they only pay attention on the concentration. They don't pay attention on the pollution load. They don't consider the wastewater flow rates. They only pay attention on the concentration. Do you know why? In case of Thailand and probably many other countries, we have the pollution sources as many as 100,000, over 100,000 sources all over the countries. So it's impossible to monitor. It's impossible to really look into which source discharged more or discharged less. But checking the concentration is much easier. They just take the sample and then measure. And if they find the BOD is greater than 20 milligrams per liter, they will issue the warning to that industry. Second warning will be fine, but third warning, the industry has to stop the manufacturing process. That would be the penalties to the industry. So this is a kind of the comparisons between the government stipulation approach and the minimum degradation. Minimum degradation, they actually focus both concentrations and the flow rate. But in reality, minimum degradation is impossible because the pollution sources all over the countries, all over the world, they are unaccountable. It is impossible to check or to monitor the amount of water used. So this is the comparisons. Some of the government stipulation also has some advantages and some disadvantages is still there, but the minimum degradation they consider both in terms of volumes and the concentration, but in reality it's impossible to measure the volumes for all the times. That is why most of the governments, most of the authority in charge, they are just to set the standard based on the governmental stipulation. Okay, so
อาจารย์
this
ค
is
รับ
the ครับ
ไอ้
ครับ
สรุปไอ้ pollution load มันคืออันเดียวกันกับ organic load ใช่ไหมครับ
the same pollution load คือ the same as the it's not the same it depends on what types of the pollution. So if you pay attention on the organic, so we can say the organic load instead of the pollution load. So if you focus on the suspended solids, you can say suspended solids load. คือ pollution นี่เป็นคำกลางๆไงฮะแต่ว่าถ้าเราดูตัวไหนตัวหนึ่งนะฮะเราก็อาจจะเรียกเป็นการเฉพาะของตัวนั้นไปเลยแต่ว่าin general เนี่ยมันคือ load นะฮะมันคือ load นะฮะ
ครับอาจารย์ครับ แล้วจริง ๆ แล้วเขาดูแค่ BOD ป่ะที่อาจารย์บอกอะ
ใช่ก็คือเดี๋ยวนี้เขาดูแค่ concentration เขาดูแค่ concentration เขาไม่ได้ดูflow นะฮะเพราะว่า flow เนี่ยเป็นสิ่งที่วัดได้ยากในทางปฏิบัติก็จริงๆก็ไม่ยากหรอกคือถ้าเป็นอุตสาหกรรมขนาดใหญ่เขาก็จะมีการลงทุนในเรื่องของมิเตอร์แต่ถ้าเป็นแหล่งที่มันเป็นแหล่งขนาดเล็กนะฮะบ้านเรือนขนาดเล็กพวกอุตสาหกรรมขนาดเล็กเขาไม่ได้มีการติดตั้งไอ้เรื่องของการวัด flow เพราะฉะนั้นเนี่ยการเช็ค flow เนี่ยเป็นสิ่งที่ทำได้ยากนะฮะนะครับคือ minimum degradation เนี่ยนะฮะเป็น best practice in terms of the theory point of view but in reality เนี่ยนะฮะminimum degradation เนี่ยนะครับcannot be implemented นะฮะเพราะว่าอะไรเพราะว่า stream เนี่ยนะฮะมันไม่ได้มีแค่มันไม่ได้เป็น single stream นะแต่ว่ามันมีconnection นะฮะจากone stream two stream and many other streams joined together นะครับ so it's created a complicated ecosystem so it's impossible to evaluate it one by one stream by comparing with another stream นะครับอันนี้คือความแตกต่างระหว่างtwo approach นะฮะokay now the next issues related to the minimum degradations is if you really have a look at this slide เดี๋ยวนะ
อาจารย์ครับ เมื่อกี้ตอนเราแปลงหน่วยจากมิลลิกรัม per day เป็นกิโลกรัม per day เราแปลงยังไงนะครับ
เดี๋ยวนะ where are we now okay เดี๋ยวนะ
คูณ 10 กำลังลบ 3 ป่ะครับ
มิลลิกรัมเป็นกิโลกรัมนะฮะ you have to multiply by 10 to the power of minus 6 ใช่ไหม so in order to convert milligrams into kilograms you have to multiply by 10 to the power of 6 right and then this one again liters so if you want to convert liters into cubic meters you have to multiply by 10 to the power of minus 6 okay so overall you just multiply by 10 to the power of minus 3 in order to convert this amount into a kilograms per day. That is why this one into this concentrations in terms of milligrams per liter just multiply by 10 to the power of minus 3. So you get 100 kilogram per day. Okay.
ครับ
Another aspect related to the minimum degradation is the Diels-Sachs profile. What is the Diels-Sachs profile? Sachs in Thai actually means Sachs นี่แปลว่าตกท้องช้างนะฮะ Diels-Sachs profile Sachs นี่แปลว่าตกท้องช้างนะครับso the this of oxygen just think about the river just think about the rivers okay so this is the point of this chart this is the point of this chart if the waste is discharged at this point waste contains some certain amount of the organic substance okay the organic substance, once it get into the water, what will happen? The organic substance, once it get into the water, what will happen? Some certain amount of the organic substance will react or will be degraded, and oxygen in the river get utilized. So the dissolved oxygens in the river will get utilized, and if you measure the concentrations, it will be lower somehow, because some certain amount of the oxygens is utilized by the microorganisms to degrade the organic substance. So just like I explained it to you, self-purification process. In self-purification process, oxygens in the river get utilized. So oxygens in the liver get utilized by the microorganisms. Okay, so finally, the oxygen concentrations in the river will get lower. Remember that the oxygens, dissolved oxygens in water. The dissolved oxygens in water in general, you can find the value like a saturated DO. Do you have any idea about the saturated DO in the nature? Saturated dissolved oxygens in the nature. So how much oxygens can dissolve in to the water? 2, 4, 5. So maximum concentrations that you could find the oxygens in the nature, it's around 7 something. It's already saturated. So if you aerate it like you feed, you have the fish in your house, and then you put the oxygens into the water all the times, and then if you measure the oxygens, you will get value in between 7 to 7.5. Maximum is a 7.8. You will never see something beyond 8, except some places where there's plenty of algae in the ponds. Okay, during the daytimes, lots of photosynthesis take place, and then if you measure the oxygens in the ponds containing lots of algae at 3 o'clock in the afternoon, you may get the oxygen concentration. Sometimes it goes beyond 10 milligrams per liter, but under the normal conditions, you will never see the oxygen concentrations goes beyond 8. Okay, so in between 7 to 8, it's the typical values, typical dissolved saturated dissolved oxygen concentrations. But it's common to see 5, 6, 4, 3. It depends on the amount of the organic substance get contaminated into the water. So now we have learned it. So dissolved oxygens get utilized if there is the organic substance or the BOD get into the water. So if I just plot the concentrations profile, concentrations of the dissolved oxygens are normally measured in terms of the milligrams per liter. So normally it gets like a 6 or 7, say about 6, 6.5. Okay. So it's about 6.5. So if we measure along the stream, so level of oxygens will be around 6. So once the stream reach the mixing point, this is the point where the organic substance get discharged from the probably the household or from the industry. So what will happen to the oxygens? Oxygen, some certain amount of oxygen get utilized. So the oxygens will gradually drops, right? So they drops because some certain amounts of oxygen is utilized. From a constant value, then it drops somehow. It will not drop at the point of mixing, because just remember, just imagine about the hydrological condition. Water it's flowing all the times in the stream. So when it floats, it carries the organic substance. Then the oxygen will drops to the lowest at the point of discharge. So it will drop to the lowest value somewhere downstream. Okay, it depends on the strength of waste. Okay, so and then once the organic substance get degraded and it's nearly finished, the oxygens, dissolved oxygens in water will again gradually increase to the original value. How the oxygens can actually reach back to the original value, because the oxygens from the atmosphere can actually redissolve into the water again. According to the equilibrium principle, if it gets lesser and it tends to the nature tends to increase by some way, the same as the oxygens. Once the oxygen's concentrations in water gets lower, so there's a room for the oxygens from the atmosphere to get dissolved again. So it's normally like this, the natural process. So in this case, that is why after some time, the oxygens get back to the original level. So if the organic substance is not too high, and then the lowest dissolved oxygen's value here we call the critical DO. We call it critical DO. Okay, we call the critical dissolved oxygen. So as it gets lowest, if you really have a look at the water quality, surface water quality standard, for type 3 water quality standard, the dissolved oxygen shouldn't be lower than 4 milligrams per liter. Type 3. Okay. According to the surface water quality standard, for type 3, the oxygen shouldn't get lower than 4 milligrams per liter. If it goes below 4 milligrams per liter, it will affect the welfare of the aquatic organisms. Okay, mostly the aquatic organisms are fish, shrimp, and many other types of the aquatic organisms. They don't feel comfortable to live in that water. Only some particular types of the aquatic organisms they can survive. Okay, for example, catfish. Do you know catfish? They can actually survive even the dissolved oxygen goes lower than 2 milligrams per liter. They are really strong. That is why they live in the paddy field with the flooding water in the paddy field. Do you know catfish? Catfish นี่คือปลาอะไรฮะ catfish เนี่ย
ปลาดุกครับผม
ปลาดุกนะฮะbut not for some other fish like a snakehead fish นะฮะ snakehead fish นี่คือปลาอะไรฮะ snakehead fish เนี่ยนะฮะ
ปลาไหลอะครับ
ไม่ใช่ฮะ snakehead fish เนี่ย
ปลาดูดฝุ่นครับ
snakehead head ที่แปลว่าหัวนะ snake ที่แปลว่างูเนี่ยนะฮะ snakehead
ปลา
fish
ตีนครับ
ก็คือปลาช่อนนะฮะokay, so this is the type 3. So the dissolved oxygen shouldn't go below 4 milligrams per liter. Then this is a kind of critical dissolved oxygen pattern. Then if it goes below, if the industry discharge more polluted water, so that the oxygen profiles gets like this. Critical dissolved oxygen goes below 4 milligrams per liter. So if it goes below 4 milligrams per liter, that means it could affect the qualities of water. So in that case, this industry has to pay more attention on the wastewater discharge, they can do it in two ways. The first way is to minimize the flow rate. So if they discharge more, so it will affect the qualities of water. They have to reduce the water discharged into this stream. Or the second way, it's they have to increase the treatment efficiency so that the BOD will be lower. Okay, so they can do either reduce the flow rates or reduce the concentrations. So reduce the flow rates, they can just minimize the amount of water used. So for example, in order to produce 1 ton of the products, they regularly consumes 20 cubic meters per ton. Now they have to use up to only 15 cubic meters per ton of the products. This is the water reduction approach, or reduce the flow rate discharging into the reverse. But if they want to improve the qualities of the effluent, they may have to invest some advanced technologies to minimize the to reduce the concentrations of the organic substance. They may have to apply some other processes like adsorption or some other advanced chemical reaction like a Fenton reactions to get rid of the organic substance. So this is how the industry has to do it to not allowing water in the river having dissolved oxygen less than 4 milligrams per liter. So this is a kind of dissolved oxygen profile, which has a close link to the minimum degradation, because the minimum degradation, they focus on both concentrations and the flow rate. In order to control the quality of water in the receiving stream, we can also control both flow rates and the concentration. So in this case, we can minimize the amount of waste entering to the stream. So quality of water in the stream somehow has very close link to the standards based on the minimum degradations. If we discharge more, what will happen to the dissolved oxygens? So it will get slower, and then probably the oxygens could actually finish. The oxygens in water, it's ran out. So some certain part. So some certain distance in the stream has no oxygens. So the fish living in between this area will definitely die. So if you remember several years ago, there was a news, environmental news, the boat carrying molasses. Molasses is the byproducts from the sugar production industry. They are basically the organic substance. The boat carrying the sugar molasses from the sugar production industry traveling on in the Chao Phraya River, and by accident, this boat actually sank into the Chao Phraya River somewhere in Ang Thong province, and then a lot of molasses, which is highly organic, this substance could actually use lots of the BOD value. So this organic substance, all the molasses get into the water. So at that time, the oxygen in the Chao Phraya River is completely finished. It's completely gone. Some certain distance in Jalpia rivers, the DO goes zero. So no oxygen presence. A lot of fish die, including the string gray, which has the diameters of almost 2 meters. That much largest of the string gray actually died due to that environmental contaminations episode. That you can actually search the news. These events actually happened several years ago. I'm not sure whether you can remember or not. I think over 10 years. 10 years for you, it's quite a long time. But for us, for my generation, it's not long in terms of feeling. Okay, so this is the kind of what's wrong with this one? Okay, so for the DOSAC profile in the polluted stream, that is why in this presentation, so I have classified into
อาจารย์ครับไอตัว ORG นี่มันคือออร์แกนิกใช่ไหมครับ
organic substance ครับ
พอมันลงไปในมันถูกปล่อยไปในน้ำออกซิเจนมันก็หายไปแล้วครับอาจารย์
ใช่ฮะ
ครับ
organic matter มากับน้ำเสียครับเราจะรู้ได้ยังไงว่าน้ำเสียเนี่ยนะฮะมี organic หรือไม่มีนะฮะดูจากสีและกลิ่นถ้าเป็นกลิ่นเน่าเสียที่เราคุ้นเคยนะครับนั่นคือ organic นะฮะแล้วก็สีก็คือสีคล้ำนะฮะก็ถือว่าเป็น organic substance
อาจารย์ครับ
ครับ
แล้วสรุปแล้วถ้าสมมติในกรณีที่อาจารย์ยกตัวอย่างถ้าสมมติ BOD มันต่ำกว่า4มันหมายถึงยังไงนะครับ
ออกซิเจน
มันเป็น
BOD
น้ำเสีย
คน
ใช่ไหม
ละตัวกันออกซิเจนกับ BOD คนละตัวกันนะฮะพอพูดถึงไอ้ตรงจุดนี้เดี๋ยวต้องกลับมานี่ใหม่ DO คือ dissolved oxygen นะฮะwhat I'm talking about here 4 milligrams per liter 6.5 milligrams per liter is the dissolved oxygen นะฮะ not the organic the organic it's the measures in terms of the oxygen equivalent not the actual oxygen presence นะฮะ just the oxygen equivalent นะฮะคือ DO เนี่ยคือออกซิเจนโดยตรงเลยก๊าซออกซิเจนที่ละลายอยู่ในน้ำเลยแต่ว่า BOD เนี่ยคือสารอินทรีย์ ORG organic substance นะฮะเพียงแต่ว่านะครับorganic substance เนี่ยนะฮะเราวัดในรูปของ oxygen equivalent นะฮะเราวัดในรูปของ oxygen equivalent เพราะฉะนั้นเนี่ยนะครับ oxygen equivalent ที่เราคำนวณจาก stoichiometric equation แบบนี้เราเรียกว่า stoichiometric equation นะฮะ stoichiometric equation oxygen that we obtain from the calculation from the stoichiometric equation ก็คือสมการเคมีนะฮะสมมุติว่าไอ้ตัวนี้มากตัวออกซิเจนที่จะต้องใช้ในการย่อยสลายตัวนี้มันก็มากตามไปทีนี้ออกซิเจนที่จะถูกใช้ในการย่อยสลายเนี่ยนะฮะมันก็คือในทางทฤษฎีก็คือ BOD นั่นเองนะฮะคือ BOD เนี่ยคือสิ่งที่ไม่มีอยู่จริงนะฮะแต่ว่าเป็นวิธีการวัดโดยทางอ้อมนะครับแต่ว่านะฮะออกซิเจนที่ผมบอกว่า4-5อะไรเงี้ยอันนี้คือออกซิเจนที่เป็นก๊าซออกซิเจนที่ละลายอยู่มันคนละตัวกันนะฮะมันคนละตัวกันนะครับ
แต่ครับผมเข้าใจอย่างนี้ถูกไหมคือ BOD เนี่ยจริงๆมันถ้าเรามองมันเป็น contaminant ก็คือเราก็วัดจากตรงออกซิเจนจาก contaminant ได้ไหมว่าแบบออกซิเจนมันมีเท่านี้
มันไม่ใช่การวัดออกซิเจนเลยฮะเอาอย่างนี้แล้วกันสมมุติว่านะฮะผมเคยอธิบายไปแล้วเปล่าไม่แน่ใจสมมติว่าผมมีน้ำ1 ลิตรนะแล้วผมใส่กลูโคส1 กรัมนะฮะถามว่า BOD ของกลูโคสเนี่ยเป็นเท่าไหร่ BOD ของน้ำตรงนี้จะเป็นเท่าไหร่นะฮะby the theory นะฮะyou can establish the stoichiometric equation นะกลูโคสก็คือ C6 H12O6 นะ plus oxygen then you get CO2 plus H2O นะฮะคือกลูโคสเนี่ย1 กรัมที่เราใส่ลงไปแต่ว่า BOD เนี่ยนะฮะมันจะคิดเป็น BOD เท่าไหร่เนี่ย BOD ก็คือ oxygen equivalent นะฮะ BOD คือ oxygen equivalent ถามว่ากลูโคส1 กรัม equivalent กับออกซิเจนเท่ากับเท่าไหร่ฮะเราก็ต้องอะไรนะ balance equation ใช่ไหมนะฮะ ตรงนี้180นะฮะ equivalent กับ molecular weight 32คูณ6ก็คือ192ถ้าเรามีกลูโคส1กรัมมันก็จะ equivalent กับออกซิเจนก็คือ1.06กรัมเพราะฉะนั้นกลูโคส1กรัมเนี่ยก็คิดเป็น BOD ก็คือ1.06กรัมหรือ1,000กับอีก60มิลลิกรัมนะฮะ BOD เนี่ยก็คือการคำนวณวัดออกซิเจน equivalent แต่ว่าไม่ใช่ออกซิเจนที่มีอยู่จริงไม่มีการเทียบเท่ากับออกซิเจนในความเป็นจริงเลยนะฮะพอจะนึกออกไหมกลูโคสเป็นแค่ตัวแทนของสารอินทรีย์เฉยๆถ้าสมมติว่าเรามีกลูโคส30 กรัมละลายลงอยู่ในน้ำ1 ลิตรนะฮะมันจะเทียบเท่าเป็น BOD เท่าไหร่เทียบเท่าเป็น BOD ก็เอา30คูณกับไอ้ตรงนี้นะฮะก็เป็นเท่าไหร่30,000 กว่านะฮะถามว่าออกซิเจน30,000เป็นไปได้ไหมไม่ใช่นะฮะออกซิเจนไม่มีทางถึง30,000ออกซิเจนมากสุดก็78เท่านั้นเองก๊าซออกซิเจน DO คือก๊าซออกซิเจน dissolved oxygen นะฮะส่วน BOD เนี่ยมันเป็นแค่การวัดออกซิเจนที่เอามาใช้ในการย่อยสลายซึ่งไม่ใช่ออกซิเจนที่ซึ่งไม่ใช่เป็นตัวเลขที่มีอยู่จริงนะฮะ
อ๋อครับเข้าใจแล้วครับออกซิเจนมีจริงที่จะบอกว่ามันอยู่ระดับ7 ถึง 7.8อะไรอย่างเงี้ยนะครับ
อันนั้นคือ actual oxygen dissolved oxygen แต่ว่า BOD เนี่ยมันออกซิเจนเหมือนกันแต่ว่ามันเป็นออกซิเจน equivalent ออกซิเจนเสมือนนะพูดง่ายๆทีนี้ถามว่า BOD ที่แท้จริงแล้วมันคืออะไรจริงๆแล้ว BOD มันคือการวัดไอ้ตัวนี้ฮะมันคือการเช็คปริมาณของออร์แกนิกมันคือการเช็คความสกปรกที่เป็นสารอินทรีย์เพราะถ้าถามว่า BOD เนี่ยถ้าโดย definition เนี่ยเขาเขียนว่า oxygen equivalent แต่ว่าจริงๆแล้ว BOD มันคือออร์แกนิกมันคือปริมาณสารอินทรีย์ใช่ไหมฮะเพราะว่าถ้าไอ้ตัวนี้เยอะออกซิเจนที่ต้องใช้มันก็เยอะตามไปด้วยนะครับพอจะนึกภาพออกนะครับ
นึกภาพออกครับ
okay so these are difference between dissolved oxygen and the BOD actually it's a good question because many students they mix up อันนี้นี่หลายคนผมเห็นแล้วนะหลายคน mix up กับระหว่าง2ตัวนี้นะคนละตัวกันนะครับokay so this is about the Diosec profile full screen again so importance of setting the standard so we all know that we need to have the standards without the standard so nothing will happen management that we are talking about will never been implemented management concepts that we are talking about will never been possible because the water resource is more or less like a commons do you know commons do you have the same concepts while using the private toilets and the public toilets do you have the same concepts of using so for the public toilets you just use and go sometimes you even forget to flush sometimes I mean sometimes and then you don't use it properly sometimes but in the toilets in your house so every time you use it you flush it and you clean it properly and regularly so maybe once in a week once a week you clean the toilets everything just in a well maintain the conditions for the all the facilities the faucet so if it gets blocked then you try to repair it so if there's a leak you try to fix it because if you don't fix it a lot of water you lost you have to pay so that is a kind of the private properties but if concerning about the public toilet so people I can say like most of the people not all they most of the people they tend to just use and go so they don't pay attention on the cleanliness they don't pay attention on the why they have to maintain everything in a good conditions why they have to concerns about the other people who will use after so this is the kind of the concepts of the most of the people in mind while using the public toilet the same thing as the commons the same thing as the water resources water resource is also similar to the public toilets in generally we say they are the commons, right? The commons. If we don't set the standard, so all the people, all the stakeholder, they just try to discharge the water without even any degrees of treatment, then our water as a commons water quality gets damaged. Okay, so that is why we need to set the standard. But very interesting, some scientists, they compare the environment as the commons, and then people try to extract the resource and try to discharge the waste into the environment, just like the concepts of using the public toilet. So finally, the environmental quality has been deteriorated. So these comparisons, they are more or less, considered as the tragedies of the commons. You can actually fire these articles and look for the meaning. เดี๋ยวแป๊บหนึ่งนะ Okay, so inside the Microsoft team, there's one article talking about the tragedies of the common. So you can spend some time and then have a look in a first, and if you come to the other reading materials, you will find one article. The title is "The Tragedies of the Commons." In here, by Garrett Hardin. So you can go through it. Just try to get some idea about how we can apply these concepts to manage the environmental quality. This article contains 10 pages. They actually are more on a social issue, not just the environmental issues. This is, I think, as the engineer, you should actually concerns about the commons from now on, because from now on we are talking about the sustainable developments. So do you understand this word, the sustainable development? So what does it mean? Sustainable development.
การพัฒนาอย่างยั่งยืน
รู้แล้วนะฮะแล้วยั่งยืนมันแปลว่าอะไรในที่นี้นะฮะ What does it really mean by sustainable? The sustainable developments, it's a kind of we are trying to use the resources by concerning the next generations. Like nowadays we are using the fossil fuel, and then we have to concerns for our next generations, for our sons, for our daughters, for our nephews in the futures, how they will spend, how they will live, because they are also depending on these resources. So we have to create the technology which tends to save the water, save the fuels, maximize the efficiencies of the fuels, or we tends to use other types of the technologies which are used the less resources, so that we have to be ensure that our next generation will still have sufficient resource for future living. So this is a kind of sustainable development คือจะทำอะไรก็แล้วแต่เนี่ยเราต้องนึกถึงคนที่จะต้องอยู่อาศัยในอนาคตไม่ใช่ว่าใช้ทรัพยากรทุกอย่างให้มันหมดไปนะฮะ this is the real the concepts of the sustainable developments. The vehicle, the use of the fossil fuel and replaces by other types of the fuel, that is another issues. In terms of the resource management, that is one issues. But in terms of the air quality, so today the air quality has gone bad due to a use of extensive use of the fossil fuel. So then how we can keep the air quality better for the next 10 years? How we can keep the water quality in the rivers or in the lakes for the next 50 years or the next 100 years. So remember that the previous generation, they have keep the environment in a good condition for us. Then we have to keep this good condition for the next generations. In the past, Klong San Sap is not the quality. It's not that bad as compared with the present. But from because in the past they don't dispose lots of wastewater. So by the same concept, so we have to keep everything, try to minimize the environmental discharge, or apply new management concepts to keep it going without the contamination, without the disturbing the environmental quality. That is why now most of the engineering works, especially the mega projects, larger projects, before implementing the projects, you have to study the environmental impact. So it is required by law now. Okay. Okay, so this is the major idea about the chapter 2, importance of setting up the standard. Anything I need to emphasize? So this one I have already mentioned. The water quality. We classify the parameters. We can actually classify it into 3 to 4 groups: physical characteristic, chemical characteristic, biological characteristic. And in order to control the parameters which can be used as the indicators to monitor is the coliform bacteria. Coliform bacteria is actually a group of the microorganisms that present in the human intestine, and especially in all mammals, intestine contains some types of the microorganisms, some bacteria, which normally called coliform bacteria, so that these microorganisms or these bacteria normally exist in the human's body or in the mammal's body. They never exist in the environment. So if it exists, if we could find it in a water, it means that that water gets contaminated with the human's excreta. So it's a good indicator. So we normally don't find this coliform bacteria in the nature, but if we find it in the water, it means that the water get contaminated with the human excreta by some way. Okay. Last year, before the outbreak of the COVID-19, I have investigated samples from ice, collect buy it from the canteen, and some water that I have collected from the fountain ไม่ใช่ fountain สิเขาเรียกว่าอะไร ไอ้ตู้กดน้ำอะนะฮะin the labs in hydraulics labs and also in the environmental engineering labs all the samples surprisingly I have found some microorganisms there but not much not high but finally I could find some microorganisms there in fact it shouldn't be there that is why soon after I fired then I asked the maid the housekeeper to clean up so it's important we clean it regularly so even though we have good facilities providing the drinking water for the students but it's important to clean it regularly I think at least once a week clean it the machine in everywhere okay so this is the microbiological quality other things probably I think you can have a look by yourself but okay that is all for the chapter 2 so next week we will come back with the chapter 3 anyway we still have times like another half an hours our lectures is not end yet I think it is about the time that I just try to distribute the quiz you haven't received it as yet the quiz so just wait for a few minutes I think the quiz so I made them automatically send it to you 12 o'clock if there is nothing wrong
จ้าครับมีควิซต่อจากนี้ใช่ไหมครับ
ใช่ครับบัตรนี้แหละฮะ
โอเคครับ
บัตรนี้เลยละครับเกี่ยวกับ pollution load นะฮะschedule ทำไมมันยังไม่ไปdue date assignment timeline 12:30 p.m.น่าจะสักแป๊บหนึ่งนะฮะ if it doesn't come in a few minutes then I will again resend it sometimes it takes almost 5 minutes to reach you during waiting maybe I can just show you the question pollution load okay it's here okay this is the quiz อันนี้เห็นหน้าจอของผมใช่ไหมฮะ pollution load communities with the populations 6,000 averagely consumes water of 250 liters per capita per day while wastewater generated from this community contains an average BOD 150 milligram per liter. Determine a wastewater generation rate and the organic loading rate in terms of cubic meters per day and kilograms BOD per day, respectively. So this is about the domestic wastewater. So this is the first question. Wastewater generation rate. Wastewater generation rate Okay, so the next is sentence is if the loss and waste is accounted for 15%. If the loss and waste is accounted for 15%, compare the organic loading rate of the domestic wastewater, industrial wastewater discharged from various manufacturing process as listed in the following table. And also determine the population's equivalence in each industry. Indicates what type of industry create largest amount of waste. ทำไมควิสมันไม่ไปอ่ะหรือผมตั้งอะไรผิดพลาด
ตาครับออร์แกนิกเรทมันคิดยังไงอะผมคิดแค่ pollution ที่แบบมันเอาคิวคูณกับไอ้ BOD แค่นั้นอะ
เหมือนกันครับ organic loading rate ก็คือตัว Q คูณกับ BOD เช่นเดียวกันฮะเหมือนกันนะฮะก็นี่ไง organic loading rate อะนะฮะ expressed in terms of kilograms per day but the target pollutants that we are interested according to this question is is BOD. That is why it comes as the kilograms BOD per day. นี่ไงไปละนะฮะได้หรือยังครับควิสเนี่ยนะฮะนี่อุตส่าห์ตั้งเที่ยงนะมันมาเที่ยง5 นาทีแสดงว่าแบบมันมีดีเลย์นะฮะควิสในอะไรนะใน lab อ่ะผมถึงได้ตั้งไว้15 นาทีปกติผมให้เวลาแค่10 นาทีเองนะเผื่อดีเลย์อีกประมาณ 3-5 นาที so how we can solve this problem
อาจารย์ครับ
ครับ
คือผมเข้าไปในทีมของอาจารย์ยังไม่ได้แต่ว่าผมสามารถจอยในอาจารย์ได้ครับ
ฮะยังไงนะไม่เข้าใจ
คือผมสามารถจอยเข้าไปในเนี้ยในที่อาจารย์สอนอยู่ได้แต่ว่าผมไม่สามารถจอยทีมแบบว่าที่จะมี assignment หรือที่จะมีนู่นนี่นั่น
เหรอแสดงว่าคุณยังไม่ได้เป็นเมมเบอร์เหรอไม่น่าใช่นะเดี๋ยวนะผมขอเช็คแป๊บนึงตอนนี้คุณนั่งอ่านควิสไปก่อนชื่ออะไรนะฮะเมื่อกี้นี้
ชัยกิจครับ
โอเคไอ้นี้มันไม่มี
เหมือนพาสเวิร์ดของทีมที่ทางคณะส่งมาให้มันไม่ถูกหรือยังไงไม่รู้ครับ
เหรอมีใครมีลักษณะแบบเดียวกันแบบนี้บ้างฮะชยกฤษสัตตวลินยูนี่หรือเปล่า
ได้ครับ
ตอนนี้ผมเพิ่มเข้ามาในทีมเมมเบอร์แล้วแต่ว่าไอตัวควิสเนี่ยอาจจะต้องส่งมาเองทีหลังอ่ะ
ได้ครับเดี๋ยวทำไงดี
เดี๋ยวผมอัปโหลดไฟล์ตัวนี้เข้าไปในโพสต์ของกลุ่มทำไมมันออกมา2 อันเป็นทั้ง assignment แล้วก็เป็นทั้งมันอยู่ในโพสต์คุณสามารถที่จะดาวน์โหลดไอตัวน่าจะดาวน์โหลดจากไอตัวโพสต์ตรงนี้ไปได้คุณดาวน์โหลดจากโพสต์ในกลุ่มไปได้หรือยัง
ชื่อไฟล์ว่าอะไรนะครับอาจารย์
pollution load
มันมี2 อัน
มันมี2 อันเนี่ยไม่แน่ใจว่ามันด้วยเหตุอะไรมันถึงได้มี2 อัน
อันไหนก็ได้ใช่ไหมครับ
แต่มันคืออันเดียว
อันแรกไม่ได้ It look like you haven't been asked
ถ้าอย่างนั้นคุณก็ไม่น่าจะได้ละงั้นก็มา
อันที่2ก็ไม่ได้
ของผมมันได้แค่เปิดได้ครับอาจารย์แต่โหลดไม่ได้
เดี๋ยวรอสักครู่ไอ้ที่เปิดได้โหลดไม่ได้เนี่ยเดี๋ยวรอสักครู่มันอาจจะเป็นเรื่องของ connection ที่ไปมา ตอนนี้เดี๋ยวผมอัปโหลดเข้าไปใน class material ด้วยนะฮะแต่ว่ามันน่าจะอยู่ในโพสต์ตอนนี้คุณสามารถที่จะคลิกตรงโพสต์แล้วก็โหลดไฟล์ไอ้ตัวนี้ไปได้เลยอันนี้ไม่ได้ส่งในระบบ assignment นะ
อาจารย์คะอันนี้ให้เขียนส่งเป็นแบบเขียนแยกออกมาเลยหรือว่าให้เขียนคำตอบไปในช่องคำตอบเลยอะค่ะ
เขียนเป็นช่องคำตอบมาก็ได้ครับแต่มันอาจจะไม่ตรงนะฮะช่องคำตอบเนี่ย
หมายถึงว่าคือที่พวกหนูได้มันเป็นคล้ายๆเหมือน
ตอบเป็นช่องใช่ไหมฮะ
มันเป็นรูปอะค่ะแต่มันจะเป็นช่อง enter your
ช่อง
answer
ตอบข้างล่างโอเคคุณเติมลงไปในช่องนั่นแหละ
โอเคค่ะ
ก็คือก็อาจจะบอกว่าammunition อะไรนะเท่าไหร่อะไรอย่างเงี้ยแต่ว่าคำถามข้อนี้เนี่ยนะครับthis question actually contains a number of a small question please pay attention it is not just filling up the values into the table that I have given okay so maybe I try to explain it from this so how can I write something into list files probably just do it like thisเดี๋ยวนะ desktop screenshot in OneNote นี่มันโพสต์ได้ไหม
อาจารย์ครับอะไรคือ proposition equivalent เหรอครับ
เดี๋ยวจะอธิบายให้ฟังเดี๋ยวก่อน insert a picture
ได้ครับแต่ผมยังเปิดไม่ได้เลยนะดูว่ามันยังได้แล้ว
เปิดในไฟล์ในโพสต์แทนก็แล้วกัน
ไฟล์ในโพสต์
ควิสนี้ไม่คิดคะแนนไม่คิดตังค์แล้วกันโอเคเดี๋ยวนะso okay now ตอนนี้ผมอยู่ในหน้า OneNote นะฮะokay so for the first question you need to have a look here wastewater generation rate and the organic loading rate so this is the first question the first question is population is 6,000 and each individual persons actually consumes 250 liters per capita per day. Wastewater generation rate from these communities contains the average BOD of 150 milligrams per liter. Answer to the first question here. So how you can determine the wastewater generation rate. So we have 6,000, right? People in these communities. And one used 0.25 cubic meters per persons per day. So the overall wastewater generation should be approximately this cubic meters per day. 6,000 into 0.25. There are 6,000 people living in these communities, and then each person use up to 0.25 cubic meters or 250 liters per capita per day. So total water use is this much เท่าไหร่ฮะตรงนี้ 6,000 into 0.25 cubic meters per
ครับ
ฮะ.25 คูณ 6,000 เนี่ยนะ
1,650 นะครับ 1,650 ครับ
ทำไมเป็น 1,650 อ่ะ
6,600
1,500 ครับ 6,000 คูณ 0.25
6,000 นะฮะ
โอเคครับโอเคครับ
เป็น1,500 นะอันนี้คือwater use นะฮะอันนี้คือ water use นะครับ cubic meters per day นะ so this is the water used in terms of water used cubic meters per day. But if the loss and waste is accounted for 15%, the thing is we used suppose we use 250 liters per capita per day, but this water after being used it becomes a wastewater. It doesn't always mean 100% of the water used becomes a wastewater. If you wash your car, so you lost some amount of water. So only 85% of water becomes the wastewater. Okay, so 15% of water use is lost. คือ 15% เนี่ยมันหายไปจากกิจกรรมบางกิจกรรมที่น้ำเนี่ยมันไม่ได้ถูกรวบรวมอยู่ในระบบท่อนึกออกไหมฮะเพราะฉะนั้น wastewater generation rate เนี่ยจะเป็นเท่าไหร่ก็ต้องคูณด้วยอะไร so only 85% becomes a wastewater ใช่ไหมนะฮะ so you can finally get 1,500 into 0.85 so this is the answer to the first question wastewater generation rate. So this is the answers to the first question. 0.15 into 0.85. Sorry, 0.85 into 1,500. So what would be the value? เท่าไหร่อ่ะ 1,275 1,275 okay. Then the organic loading rate. So this is the wastewater flow rate, and the domestic wastewater contains some BOD 150 milligrams per liter. So if you want to express in terms of the organic load and the unit is kilograms per day, so you have to take 1,275 into 150. Just convert the unit. Then you will get in terms of kilograms BOD5 per day. So what will be the value เท่าไหร่ฮะกี่กิโลเดี๋ยวผมหาก่อนได้เท่าไหร่ครับ
ได้ 12,125 ครับ
อะไรนะ
19,125 กิโลครับ
ฮะ 10,000 เหรอ
ก็มันได้1,900,000อาจารย์
1275 191.25 ใช่ไหม
ครับ
เป็นกิโลอ่ะครับกิโลมันต้องคูณ10 กำลังลบ 3มันก็ต้องเป็น
ไม่อันนี้เมื่อกี้บอกไปแล้วไงมิลลิกรัมต่อลิตรกับอะไรนะลูกบาศก์เมตรต่อวันใช่ไหม
ครับอันนี้เข้าใจครับอาจารย์
เป็นกิโลกรัมคูณ10 ยกกำลังลบ 6ไอ้ตรงเนี้ยเปลี่ยนเป็นลูกบาศก์เมตรคูณ10 ยกกำลังลบ 3เพราะฉะนั้นรวมกันคูณ10 ยกกำลังเลยฮะ
ลบ 3มันก็จะได้ 1,912.5 เลยครับอาจารย์กิโลกรัม
1,000 คูณกับ150คูณ10 ยกกำลังลบ 3
ทีแรกอ่ะไอ้ 1,000 คูณ150คูณ10คูณ10 กำลังลบ 3โอเคครับโทษที ผมไม่เห็น-3อาจารย์ขอโทษทีครับ
อันนี้ก็ไปแล้วสองคำตอบนะ ไปแล้ว2คำตอบ ทีนี้ถัดมา ammunition นะฮะ
อาจารย์ครับ
Organic
1275
Yes
คือเลขอะไรอะคะ
This one is actually the wastewater generation rates. It's essentially comes from water consumption, right? 250 liters per capita per day. Okay, 250 liters per capita per day, or 0.25 cubic meters per day. So this is the water used for just one person. But in these communities, there are 6,000 people. So water used in this community, it's 1,500 cubic meters per day. But the problem is here. Loss and waste is accounted for 15%. So we use water. Suppose we use water 100 liters per day, but it doesn't mean that. So this is a tap water. It doesn't mean that this 100 liters becomes a wastewater, because this 100 liters are some amount of water we drink, some amount of water we just watering, some amount of water watering the plants, so some amount of water we wash our car. So only 85% of this becomes a wastewater. So loss and waste is 15%. So if you take this amount and multiply by 85, so it becomes a wastewater. So you will get 1,275 cubic meters per day, 1,275. Okay.
จ้าครับแล้วสมมุติในกรณีของควิสเนี่ยเราก็ต้องเอา 6,000 เอา 6,000 ไปคูณกับ 0.25 คูณกับ 0.85 แล้วก็ได้เลขออกมาแล้วค่อยมาคิดเป็น organic loading เหรอครับ
ใช่ฮะใช่เพราะว่าไอ้ตัวนี้คือ wastewater มันมี2คำถามไง wastewater generation rate นี่คือคำถามที่1อันนี้คือคำตอบคือของคำถามย่อยที่1
โอเค
แล้วก็organic loading rate นี่คือคำถามย่อยที่2this one is the answer to the question number 2 อันนี้คือ2คำถามย่อยนะฮะ
อ๋อเก็ตแล้วครับคือไอ้ทั้ง6 1 2ทั้ง5ตัวเนี่ยผมก็ต้องทำแบบนี้เหมือนกัน
ไม่5ตัวนี่คืออะไรฮะเดี๋ยว
มันต้องหาอันที่มากที่สุดในการที่จะปล่อยแบบว่า
ใช่อันนี้คือจบไปละคำถามถัดไปเนี่ยก็คือเขาถามว่าให้หาorganic loading rate ของแต่ละตัวนะฮะammunition
เพื่อหลายคนงงครับอาจารย์
ammunition เนี่ยคำถามที่คุณต้องอ่านให้ดีนะคำถามผมเป็นอย่างนี้เยอะนะบอกไว้ก่อนนะ
โอ้ตายเรียบไปครับอาจารย์เพื่อน
คำถามอย่างนี้ผมมีเยอะนะคืออ่านคำถามเนี่ยต้องอ่านให้หมดทั้งอะไรอะทั้งหมดเลยอะแล้วก็ค่อยลงมือทำนะฮะอ่านให้หมดก่อนแล้วค่อยลงมือทำนะฮะทีนี้อันต่อไปเนี่ยเขาให้หาแต่ละอันใช่ไหมแล้วก็อันไหนเนี่ยนะครับผลิตdischarge waste เยอะที่สุดอันแรก ammunition นะฮะ100นะครับแล้วก็BOD เนี่ยน้ำเสียเนี่ยนะครับไอ้ตรงนี้คือin the range of 50 to 300 แล้วก็ typical เนี่ยคือ200ปกติเราก็จะใช้แค่ค่า typical ไปใช้ในการคำนวณนะฮะอันนี้คือเป็นการบอกไอเดียเฉยๆว่าปกติเราวัดได้เนี่ยมันจะวัดได้ตั้งแต่50นะจนกระทั่งถึง300แต่ว่าส่วนใหญ่ most of the time เนี่ยนะฮะคือ typical value เนี่ยก็คือ200เพราะฉะนั้นไอตรงนี้คือเท่าไหร่ฮะorganic loading rate ของ ammunition นี่น่าจะเป็นอุตสาหกรรมเกี่ยวกับพวกวุธหรือเปล่า
20ป่ะครับ
20ใช่ไหมแล้วตัวถัดไปก็จะเป็นเท่าไหร่
4,500 ครับผม
แล้วตัวถัดไปก็จะเป็น
750
แล้วตัวถัดไปก็
2,000 ครับ 2,000
นะ 2,000
แล้วก็ 2,500 ครับ
แล้วก็ 2,500
ครับ
so which one are create largest amount of waste อันไหนปล่อย
fermentation ครับ fermentation
4,500fermentation ก็คือพวกอุตสาหกรรมการหมักอย่างเช่นพวก ethanol นี่ก็ถือว่าเป็น fermentation นะฮะ ethanol production ที่เราจะเอาไปผสมใน gasoline additive หรืออะไรต่อมีอะไรต่างๆพวกนี้ก็มาจากเป็น fermentation slaughterhouse นี่โรงฆ่าสัตว์อันนี้รู้อยู่แล้วเนาะtannery นี่น่าจะเป็นพวกฟอกย้อมนะฮะpulp and paper ก็จะเป็นพวกโรงเยื่อนะครับโอเคอันนี้คือorganic loading rate นะฮะthen the last questions is the population's equivalence population's equivalence เนี่ยนะฮะก็คือone person's how many kilograms per day that one person's generated one person's generated the waste how many kilograms per day คนหนึ่งgenerate waste เท่าไหร่ฮะคนหนึ่งโอ๊ยอะไรเนี่ยone person's generated organic loading how much that one person's generated the organic loading คนหนึ่งเนี่ยผลิตโหลดขึ้นมาเท่าไหร่ฮะคนหนึ่งใช้น้ำเท่าไหร่ครับคนเดียว
1.14 กรัมป่ะครับอาจารย์
one person's เนี่ยคือใช้น้ำ0.25 ลิตรถูกไหมฮะ
0.25 ลิตรโอเคครับ
0.25 ลิตรใช่ไหมลูกบาศก์เมตรต่อวันอันนี้คนเดียวนะแล้วก็คนเดียวเนี้ยนะฮะใช้น้ำเท่านี้แต่ว่า but becomes a wastewater เนี่ยก็คือ only 85% ใช่ไหมฮะแล้วก็one person's เนี่ยนะฮะthe waste discharged from one person also contains the BOD 150 นะฮะ milligrams per liter and again we just find the load for one person's organic load for one person's how many kilograms per day per person one person's คน
มันเป็น 31.875 คูณ 10 กำลังลบ 3ป่ะครับ
อันนี้คูณ 10 กำลังลบ 3
ใช่ครับมันเป็น 31.875 คูณ 10 กำลังลบ 3
ได้เท่าไหร่ฮะ
แป๊บนึงครับ
0.03
0.03 ครับอาจารย์
ประมาณ 0.03 นะฮะ
ใช่ครับ
อันนี้คือโหลดดิ้งที่ผลิตขึ้นมาจากคนหนึ่งนะฮะคำว่า population equivalent เนี่ยนะฮะ in this context means suppose this industry they generate the waste 20 kilograms per day เนี่ยนะฮะequivalent to how many persons generated the waste นะฮะนึกภาพออกไหมคือคืออุตสาหกรรมเดียวเนี่ยเทียบเท่ากับคนกี่คนที่ทำให้เกิด waste ในปริมาณเท่ากัน
อันนี้
เพราะฉะนั้นอันนี้ one person generates 0.03 kilograms per person per day ถูกไหมฮะทีนี้ไอ้ตรงนี้ก็คือมี20 so population's equivalence can be determined by taking 20 divided by 0.03 so you will get the number of persons
666 คน
เท่าไหร่ก็ไม่รู้
666ครับ
6 persons then this one is 4,500 so equivalent to how many persons
อันนี้ 150,000 ครับ 150,000 คน
เพราะฉะนั้นเนี่ยนะฮะอินดัสทรีเดียวเนี่ยเทียบเท่ากับคนถึง 150,000 นะฮะในการ generate waste ในปริมาณเท่ากันนั่นแสดงให้เห็นว่ายังไงโรงงาน1โรงงานนี่ผลิต waste เยอะนะฮะนะครับคือ population equivalence เนี่ยgive a sense in terms of comparisons give a comparison a sense อันนี้พอจะนึกภาพออกเลยใช่ไหมฮะในแต่ละอัน
ครับผมอาจารย์อธิบายนี่ตายกันเรียบครับ
ฮะอะไรกันอันนี้เป็นเรียกว่าอะไรนะโอเคคุณอาจจะไม่รู้จักคำว่า population equivalent แต่ว่าcalculation procedure เนี่ยมันก็ common นั่นแหละมันไม่มีอะไรซับซ้อนนะวิชาขั้นสูงเนี่ยก็จะเป็นลักษณะอย่างนี้แหละก็คือส่วนใหญ่แล้ว calculation procedure เนี่ยเราไม่ได้ใช้ sin cos tan differential integration อะไรขั้นสูงหรอกแต่ส่วนมากเราจะใช้ logic นะในการคำนวณในการคิดในเชิงเปรียบเทียบหรืออะไรต่อมีอะไรต่างๆนะครับก็ประมาณนี้นะฮะอันนี้คือ quiz นะฮะ เอามาให้ทดลองทำเล่นๆในห้องเฉยๆนะครับอันนี้ไม่ต้องส่งก็ได้นะอันนี้เนี่ยไม่เอาไปคิดอะไรนะครับโอเคมีข้อสงสัยเกี่ยวกับควิสไหมฮะ Do you have any question regarding to the quiz or today's lectures มีไหมครับ
ควิสกับมิดเทอมอันไหนยากกว่าครับทำเลเวลความยากพอๆกัน